we are going to solve one example, which is 14-1, in which all these forces are acting, and we need to find out the work done due to these forces. So I hope that example 14-1 slide is visible to all of you. Okay, first of all, reading the statement of this example, you have a 10 kg block shown which rests on a smooth incline. So for simplicity, it is given to you that the inclined plane is smooth, so we are not going to include friction in this case here. So if the spring is originally stretched 0.5 meters, so initially this particle is located at this position. Let us say that this is our position number 1, and at this position the spring is already stretched 0.5 meters. So इस पोजीशन के ऊपर जो पोजीशन 1 है, स्प्रिंग जो है वो 0.5 मीटर ऑलरेडी अपनी न्यूट्रल पोजीशन से स्ट्रेच हुआ हुआ है. आप करते क्या हैं कि यू अप्लाई अ हॉरिजॉन्टल फोर्स P, which is equal to 400 Newton on this particle. As a result of this force, this particle is going to move up that incline. So once this particle has traveled a distance of 2 meters up that incline, so our position 2 would be this position when this particle has traveled a distance of 2 meters from position 1 up this incline. You need to find out the work done by all the forces acting on the block as shown to you in the figure. So due to the application of this horizontal force P, the particle is going to move upward a distance of 2 meters. You need to find out the work done by all the forces acting on this particle. So starting with drawing the free body diagram of this particle. So let us draw the free body diagram of this particle. So in order to draw the free body diagram, the weight of this particle would be acting vertically downward. Then you have a force of 400 Newton, applied force P, 400 Newton, which is acting along the x-axis. Then there is going to be a normal reaction force. Why we are going to have a normal reaction force? Because we are going to remove this inclined plane. So once we remove this inclined plane, we are going to get a normal reaction force which would be acting perpendicular to the contacting surface between the particle and the inclined plane. So these are the three forces which we can identify. Can you identify some more forces which we need to draw on the free body diagram?
Spring force include, yes sir, towards the spring होगा.
So spring force भी आएगी. So spring force क्या होगी? Up that incline होगी या down the incline होगी?
Down incline.
Up the incline.
Why up the incline? Spring जब stretch होता है, so what does this spring force act? It would act in a direction to move the spring back to its unstretched position. So चूंकि position 1 पे already spring stretch हुआ हुआ है, इसको आप मजीद stretch कर रहे हैं to position 2. So the spring force would act in this direction. That is, it is going to act downward in order to restore this spring to its neutral position, isn't it?
Yes, sir.
Okay, so these are the four forces which would be acting on this particle. What about force of friction?
Smoother तो नहीं होगी force of friction.
Okay, so since it is given that the incline is smooth, so friction force would not be acting. However, if the incline is not smooth, then the friction force is going to act down the incline, that is opposite to the motion direction or opposite to the relative motion. Is it clear to all of you?
Yes, sir.
Okay, so since friction force is not involved here, so let us move to the solution of this problem. कि अभी हमने जिस तरह बात की, this is going to be the free body diagram which is shown to you here on the lower right side of this slide, the free body diagram which we constructed in the previous slide. So these are the forces. One is the applied force, friction, one is the applied force, the other one is the spring force, normal reaction force, and the weight which would be acting downward. Okay, now one by one we are going to calculate the work done due to all these forces which are being involved here, starting with the horizontal force P. What should be the work done due to this horizontal force P? Can any one of you tell me?
P into horizontal जितना distance हमने cover किया सर वो 0.5 cos 30 आएगा.
This is our position number 1. This is our position number 2. So from 1 to 2, what is going to be the work done due to this applied force? It is going to be that applied force multiplied by displacement. However, since P and S are not along the same axis, so either we are going to consider the component of P along the direction of displacement, or we are going to consider the component of displacement in the direction of force. So as per our discussion, it is going to be 400 cos of 30 into displacement which is 2. So we are resolving force along the displacement axis. So basically हम force का ये वाला component जो है वो consider कर रहे हैं which is 400 cos of 30 and multiplying it with displacement which is 2 meters between position 1 and 2. So 2 आपके पास multiply के लिए ऐसा जाएगा. Should it be positive or negative?
Sir,
Positive, sir.
Positive, because the component of P and displacement are along the same axis. So the work done is going to be a positive quantity in this case. So UP should be equal to 400 cos 30 into 2 or 400 into 2 cos 30, whichever way you want to interpret it. So the work done would comes out to be 692.8 joules. ये आपके पास work done आ जाएगा due to this applied force. Any query regarding this work done due to applied horizontal force P? कोई query तो नहीं है किसी की?
No, sir.
Okay, moving towards the second force, which is the spring force. Now, as we have discussed earlier, that the work done due to spring force is minus half k s2 square minus half k s1 square. So, अगर हम थोड़ा सा उसको recall करें, spring force के लिए हमने work कहा था, it is going to be equal to minus half k s2 square minus half k s1 square. Can you identify K? तो हमें known है K is basically 30 newtons per meter, which is a spring constant. What about S2 and S1? अगर मैं position 1 की बात करूं, तो position 1 के ऊपर spring अपनी unstretched position से कितना displace हुआ है? Do you remember that?
1.5.
0.5, sir.
If we take a look at the question, or at position 1, the spring is being stretched 0.5 meters from its unstretched position. So it means that S1 आपका 0.5 हो जाएगा. Is this point clear to all of you? S1 किसको represent करता है? Position 1 के ऊपर spring अपनी unstretched position पे कितना displace हुआ है अपनी unstretched position से. So already question में given है कि at position 1 the spring is displaced from its neutral position by 0.5 meters. So आपके पास S1 जो है वो 0.5 हो जाएगा. Is this point clear to all of you?
Yeah.
Okay. What about S2? Already यहाँ तक 0.5 displaced था. आप मज़ीद इसको 2 meters move करते हैं from position 1 to position 2. So what should be S2 then?
2.5.
It is going to be 2.5. Now since S2 is greater than S1, और वो हमें वैसे भी नजर आ रहा है कि देखें स्प्रिंग फोर्स एक्ट कर रही है in this direction, displacement आपकी हो रही है in this direction. So work done due to spring force is going to be a negative quantity. वो वैसे भी फिर जब हम values S1 और S2 की डालेंगे 2.5 and 0.5, then the work done due to spring force is going to be a negative quantity which is going to be minus 90 joules. Is this point clear? ये कल आप में से एक का सवाल भी था, तो मैंने कहा था कि हम एग्जाम्पल 14-1 करेंगे तो आपको थोड़ा सा S1 और S2 के हवाले से क्लैरिटी जो है वो आ जाएगी. सो आई होप कि जिसका भी क्वेश्चन था उसको ये क्लियर हो गया होगा, या अगर नहीं भी क्लियर तो आप दोबारा पूछ सकते हैं.
सर ये
क्लियर?
2.5 क्यों 2 क्यों नहीं आया?
2 क्यों नहीं आया? देखिए हमने कहा क्या था, S2 किसको रिप्रेजेंट करता है, क्या आप मुझे बता सकते हैं? व्हाट डज दिस S2 रिप्रेजेंट्स? पोजीशन 2 के ऊपर ये अपनी अनस्ट्रेच पोजीशन से कितना डिस्प्लेस हुआ हुआ है. इन अदर वर्ड्स इट इज बेसिकली L2 minus L0, where L2 is the length of the spring at position 2 and L0 is the unstretched length of the spring. ठीक है, अब यहाँ हमें unstretched length तो नहीं given, लेकिन हमें इतना given है कि once this spring or once this particle is at position 1, ये spring already जो है वो 0.5 meters जो है वो अपनी unstretched position से stretch हुआ हुआ है. आप यहाँ से इसको मजीद 2 meters आगे move कर दें तो total stretch कितनी आ जाएगी? It is going to be 2 plus 0.5, which is 2.5 meters at position 2. Is it clear?
Okay, sir.
Okay. Okay. The other force which is acting here is the weight of this particle. So, what should be the work done due to weight? Can you identify it? W times delta y होगा. हमेशा जब भी weight की वजह से work आता है तो it is going to be W times delta y as far as the magnitude is concerned. W आपका कितना होगा? It is 98.1 न्यूटन What about delta y? Vertically कितना weight displace हो रहा है between position 1 and position 2? It is going to be 2 sine of 30, isn't it?
Yes, sir.
So delta y is 2 sine of 30. Weight is acting downward. What is the direction of delta y between position 1 and 2? Upward or downward delta y?
Upward.
Upward. So weight is acting downward, delta y is upward. So what should be the sign of UW? Positive, negative?
Negative.
Negative, since W and delta y are opposite to each other. So work done due to weight would be minus W times delta y. So minus 98.1 into delta y, which is 2 sine of 30. It will give you the work done due to weight to be minus 98.1 joules. Is it clear to all of you?
Yes, sir.
Okay, finally, the last force is the normal reaction force, which is NV. So what is the work done due to this normal reaction force? Can you identify it?
0, sir.
0. Why 0? Because this normal reaction force is acting perpendicular to the direction of displacement. So if any force is acting perpendicular to the direction of displacement, then cos 90 is going to be equal to 0. That's why the work done due to this normal reaction force is going to be 0. Okay, so the overall or the total work done by all the forces in moving this particle from position 1 to position 2 is going to be the algebraic sum of all these 4 work done. So taking the algebraic sum, the overall or the total work done is going to be 505 joules. Is this point clear to all of you? Because some work done are positive, some are negative. So the total work done is going to be the algebraic sum of all these work done. So it is going to be 505 joules. So this is how you can calculate the work done due to various forces being involved here. Now just a little change. Okay, if the surface is not going to be a smooth surface, then what should be the direction of force of friction then? It is going to act down the incline, isn't it?
Yes, sir.
Okay, so in that case, what should be the work done due to force of friction? Can you identify that work done?
सर नॉर्मल रिएक्शन को मल्टीप्लाई करेंगे कोफिशिएंट के साथ उसको मल्टीप्लाई कर देंगे 2 से
म्यू एनसी आ गया, उसको किसके साथ मल्टीप्लाई करेंगे?
2 cos theta.
आर यू श्योर?
सर 2 से नहीं
No, sir.
करेंगे 2 से ही करेंगे सर.
Simply 2 से करेंगे, cos theta नहीं आएगा because this friction force and displacement are along the same axis, so we don't need to include cos theta here in this term. Should this work done going to be positive or negative quantity?
Negative, sir.
Negative, since force of friction is acting downward and S is going to act upward, so UFF is going to be minus mu NC into 2. Is this point clear to all of you?
Yes.
सर.
अगर फ्रिक्शन होती तो ये वर्क डन आता, बट सिंस द प्लेन इज स्मूथ, so we have not included the work done due to force of friction in this particular example.